Now dear students, let us discuss some questions from the West Bengal State Eligibility Test. Now in this case I have taken the 2017 Computer Science and Application question paper from West Bengal SET exam, which is also called as WBSET. Now the first question that we are discussing is from programming part. So they are saying that we have four sets: P, which is having try, not, and union; Q, which is having AND, bit and complex; X, which is auto, go to, and if; and Z, which is int, void, and not. Now they are saying which of the following is correct. Number 1, element in P are C++ keywords, element in Q are C++ keywords, element in X are C keywords only but those Z are not, and elements in X and also Z are C keywords. So they are asking which of the following sets is actually containing the keyword from the C language. Now for this you should know what is the character keyword set for the C language. Actually C language is very easy because it is having the minimalistic keyword set, minimal, as compared to any other language, whether it is C++, whether it is Java, whether it is .NET or any other language. C language contains the least number of keywords, which are approximately 32. Now in case of C++, all these 32 keywords are there, but apart of this we have some extra new keywords that they have added in the C++, because C++ is just an incrementation over the C language. Now you can see in this video I have taken the keywords which are present in both C language as well as the C++ language. In both the cases these keywords exist, which are auto, break, case, char, const, continue, default, do, double, else, enum, extern, float, for, go to, if, and so on, like this. Now let us look at this set. Let us try to see what are the keywords which are existing in C++, which are not in C language. So let us try to see keywords that are not in C language. Okay, so first keyword is try. So can you see try keyword here? You can clearly see that try keyword is not there. So this keyword try is not present in C language. Now this keyword not is also not present in C language. If you can find any keyword here, then that is present in C language. Okay, as well as the keyword union, it is present in C language because union is present in here, but this try and not, these two keywords are not present in the C language. Next, in the case of Q, AND keyword, you can see AND keyword is not present in the C language. Bit and keyword is also not present in the C language. Complex keyword is you can see it is not present in the C language. So in set P and set Q they are not containing any keyword which is present in C language. The only keyword that they are containing is union. It is the only keyword which is present in C language. Now in case of X, this auto keyword is actually as you can see, this auto keyword is present. Go to keyword, this go to keyword here, it is also present, as well as if keyword. This if keyword is also present in the C language. So this entire set is present in the C language. Okay, in the set Z, int, void, and not. Int is present in C language, void is present in C language, but not is not present. So you can see void is here, okay, and int is here. These keywords are present. So this set X is containing all the keywords which are present in the C language. Okay, now let us look at for the C++. Obviously any keyword which is present in C++, I mean C++ contains all the C keywords which are the 32 keywords plus some extra keywords. Now you can see try keyword is present in C++, try is present in C++, and this not keyword you can clearly see here. This not keyword is not present in C++, and union is present. Why? Because union we have seen in the previous slide here that union is present but not is not at all present. In the next case we have AND keyword, and this AND keyword is not present in the C++, and bit and is also not present in C++, and this complex keyword, it is also not present. All these three keywords are present in C++. Int is present, void is present, and not is not present. So this X is the only set which is having, this is the only set which is having the keywords which are present in C language as well as which are present in C++, but these other sets are not having any keyword which is present. I mean they may be having some keywords which are not present in any of these languages. So the first option is saying element in P are C++ keyword, which is wrong because here we do not have the keyword not. Element in Q are C++ keyword, which is wrong. Why? Because here AND, BitAND and complex, none of these keywords is present in C++. Element in X are C keyword only, but those in Z are not. That is correct, because in case of Z this keyword is not present. And element in X and also in Z are C keyword. This is wrong, because here we have not keyword which is not present in C language. So the answer to this question is option number C. So I think you don't even need to remember this table. You don't even need to remember this table, because by practice after some time you'll find out that you can easily get the information. You can easily remember what are the keywords which are present and what are the keywords which are not present. Okay. The next question is from DBMS. It is saying for a DBMS to be used, it must minimally support which of the following operation and which of the following is correct. Now see, in case of DBMS, DBMS is generated using algebra, which is also called as relational algebra. Relational algebra. Now this relational algebra is having two kinds of operations. Number one, those are fundamental operations, fundamental operation, and second one, those are derived operations, which are also called as non-fundamental operation. Non-fundamental. Why we call it them as not fundamental? Because these operations can be derived from the fundamental operations only. So fundamental operations are the operations which are absolutely necessary to be in the relational algebra. So the fundamental operation is select, which is also represented like this. The next fundamental operation is project, which is represented like this. Next is Cartesian product. Cartesian product, which is represented by X. Next is union, which is represented by U. Next is set difference, which is represented by minus sign. And the last one is the rename keyword, rename, which is presented like this. In the derived form, we have the natural join. It can be derived from the fundamental operations. Natural join can be derived from the fundamental operations. The next one is the intersection. This intersection can be derived from the fundamental operations. The third one is the assignment operator. This assignment can be derived from the fundamental operations. And the fourth one here is the division or quotient operation. Division or quotient operation, and this division quotient operation is a fundamental, not fundamental operation. And the fifth one is the theta join, and this theta join is also not fundamental operation, because it is just a generalized form of natural join. Now they are asking here in this question, which of the following must be minimalistically supported, or minimally it should be there. So these are the keywords which are minimally should be there. So select keyword should be there. So as you can see here, the first case select keyword is there, union keyword is there, but intersection is not minimalistic, because intersection can be derived from the fundamental operations only. Next, select should be there, union can be there, and this join can be derived from the fundamental operation. Next, select should be there, project should be there, and join it can be derived. Next, select should be there, project should be there, and union should be there. So answer is option number here, 0.4 is correct, because this is the minimal set here, and this is option number A. Option number A is correct for this. And I feel the option which is given in the official answers, because in the official answers I have seen that they have given option number C, and this option number C is actually wrong in official answers. So option answers you can get it corrected over there, but I feel the correct answer is option number A for this given question. Now in the next case they are saying they are giving 4 languages, which is language L1, L2, L3 and L4. Out of these languages we have machines. For the language L1 we have machine M1. For this language we have machine M1. For the second language we have machine M2. For third language we have machine M3, and the fourth language we have machine M4. They are saying the machines recognize the language L1, L2, L3 and L4 respectively. Which one is correct? Number 1, M1 and M2 are push down automatas, but M3 and M4 are not. Now here for this we can make a push down automata, that is correct. For this we can make a push down automata, that is correct. Okay, so N1 and L2 are having push down automatas. Now they are saying M3 and M4 are not. Now in case of L3 we cannot create a push down automata, so this is correct. But L4, for this L4 we can make a push down automata, right? So for L4 language, for this we can make a push down automata. So for L1, L2 and L4 push down automata exist, and for the language L3 this Turing machine exists. For language L3 we do not have push down automata. We cannot create a push down automata for the language L3. Option number B is saying M2 and M3 are push down automatas, but we can clearly see that M3 cannot be, cannot make a push down automata for M3. So option number A and B are wrong. Option number C is saying all M1, M2, M3, M4 are PDS, which is also wrong, because for language L2 we cannot create, language L3 we cannot create. Okay, we cannot create M3 for push down automata, but option number D is correct, which is saying for language L1, L2 and L4 push down automata does exist. Next case, consider X as an n-bit number which is the power of 2, which power k of 2. Then sum of X and X minus 1 contains J zeros where. Okay, so what does they really mean? When they are saying the power k of 2, that means whatever number this X is showing, for example this X is a n-bit number like this, it is a n-bit number from here to here, correct? And it is a power of 2, that means it should be somewhere 2 raised to power k. Now you can clearly see, if you represent 2 raised to power 0, how you can represent this. 2 raised to power 1 can be represented how much? I mean, how you can represent all these powers of 2? Because if you represent all these powers of 2, then you can easily solve these questions. If we have total, assume 8 bits. Now 2 raised to power 0 can be represented like this, total of 8 zeros. Total of 7 zeros and 1 here. 2 raised to power 1 can be represented like this. We have total of these many zeros. This is 4 0 and yeah, something like this. So this is 4 0, right? So these are total of 8 bits. 2 raised to power 2 can be represented like this, 0 0 0 0 0 1 0 0. 2 raised to power 3 can be represented like this, 0 0 0 0 1 0 0 0. 2 raised to power 4 can be represented like this, 0 0 0 1 0 0 0 0. Okay, so whatever the power is, for example, if we have the power 4, that means we have 4 zeros. If we have the power 3, that means we have 3 zeros here. If we have the power 2, that means we have 2 zeros here. If we have the power 1, that means we have 1 0 in the right hand side here. Okay, now if I find it out, 2 raised to power k minus 1. Okay, so this is representing 2 raised to power k, and for 2 raised to power k minus 1, if I do 2 raised to power 0 minus 1, 2 raised to power 1 minus 1, 2 raised to power 2 minus 1, 2 raised to power 3 minus 1, and 2 raised to power 4 minus 1. Okay, why? Because you can clearly see here when they are giving this question. Now for this particular question, X is representing power k of 2 that they are writing. Okay, because consider X is an n-bit number which is power k of 2, and X minus 1 is actually minus 1 from this. So if this 2 raised to power k is X, so this will be X minus 1. So 2 raised to power 0 minus 1 is all 8 zeros. Okay, 2 raised to power 1 minus 1 is we have total of these many zeros, 4 and like this, correct? 2 raised to power 2 minus 1 means we have a 1 2 3 4, and we have 0 0 1 1, which is representing number 3. This is representing number 1, and this is representing number 0. 2 raised to power 3 minus 1 is 7, which is 0 0 0 0 0 1 1 1. 2 raised to power 4 minus 1 is 0 0 0 0 1 1 1 1. Okay, so this is, we have a correlation that in this particular case, whatever number of zeros we have, here we have exactly the same number of ones on the right hand side. Otherwise all the other digits are zeros. Okay, now they are saying if we have the sum of X and X minus 1, right? For example, X can be represented by any one of these. So assuming that X is like this, 0 0 0 0, there are some zeros and they have 1 0 0 0 0. Okay, so when they are saying that it is 2 raised to power k, that means here we have k zeros and all the other bits are here. So if total number of bits here, total number of bits are n, then in X will be having 2 raised to power X will be having n total n bits. So where k bits are 0, the k plus 1th bit is 1, otherwise all the other bits are zeros on the right hand side here. Okay, now in X minus 1 we have all the zeros here, only these k bits are 1, okay. So in total if you add both this X and X minus 1, so it will be 1 1 1 1 1 1 1 up to so on, and then we have zeros. Now you answer me how many ones will be there. So these are total of k ones. Okay, these are total of k ones, and then we have one more extra one, so which is representing k plus ones are there, and rest all the bits are 0. So in total, if we have n bits, out of these n bits, these many bits are ones, then how many zeros are there? There are n minus of k plus 1, which is representing n minus k minus 1. Okay, so answer is n minus k minus 1, which is option number A, and that is the correct answer for this given question. I hope that you understood this one, and this I feel that you really enjoyed this question. I also enjoyed solving this one. Now let us look at the question number 5. They are saying, consider the following tree. We have a tree here, and they are saying which one is correct. I mean, which of the following tree is actually representing a heap. Heap means root. Either root will be containing, we have two types of heap actually that I should tell you first of all. Heap, either we can have a max heap or we can have a min heap. Okay, so max heap means root always contain the maximum data. So in every subtree, root always contain the maximum data. Now here let us check the tree number 1. So in the first tree, out of all the data, this is the maximum data, that is correct. Now here also it is containing, root is containing the maximum data, that is correct. So T1 is representing a max heap. So T1 is representing a heap, max heap. In case of T2, in the entire tree, this is the maximum data, that is correct. In this entire tree, this is the maximum data, that is correct. But the problem is, this is not a almost complete binary tree. Okay, so heaps are generally almost complete binary trees only. Now because this is not representing almost complete binary tree, that is why it is not a heap, even though every root node is containing the maximum data. But just because root is not containing, this tree is not a almost complete binary tree, so that is why it is not a heap. So it is not representing a heap. Now in case of T3, first of all, it is an almost complete binary tree, that is correct. Now this is following the heap property. This subtree is also following the heap property, but this subtree is also following the heap property. So all the subtrees are following the heap property, therefore this is a heap. So T3 is also representing a heap. So the only tree that is not a heap is T2. Now option number A is wrong because it is saying all the trees are heap, that is wrong. Option number B is also wrong because T2 is not a heap. Option number C is wrong because T3 is representing a heap. Option number D is correct because T1 and T3, both of them are representing the heaps. Okay, so option number 3 is correct here. I hope that you understood this one. Let us look at next one. In mixed mode arithmetic operation, an integer is converted to floating point form in the following phases of a typical compiler. Generally, what are the phases of the compiler? First of all, we have the phase which is lexical analysis. We have lexical analysis. We give a high-level language program to lexical analysis, which gives a stream of tokens. Now from this lexical analysis, we give it a syntax analyzer. Now from this syntax analyzer, we get a parse tree which we give to semantic analyzer. Semantic analyzer. From this semantic analyzer, we give intermediate code generation. Intermediate code generation. Now we give the intermediate code generation to code optimizer. And from this code optimizer, we generate the target code generation, which gives us an assembly language program. Okay. Now they are saying an integer is converted to floating point form. So an integer cannot be converted to floating point form in the lexical analysis, because here lexical analyzer is not doing any kind of conversions. So lexical analyzer is just to give us a stream of tokens, remove extra white spaces, remove comments, but it is not converting an integer to a floating point form. So this one, option number A, is actually wrong. Option number B, parsing, is also wrong, because parsing is just checking whether the program is correct or not. I mean, it will create a parse tree. It will create a parse tree, but it is not converting it. But option number C is semantic analysis. In case of semantic analysis phase only, in this phase only, we convert integer is converted to a floating point number. Only in this phase we perform some action. Otherwise, in the first two phases, we do not perform any kind of action like this. They are just checking whether the program is correct or not. So option number C is matching, and option number D is wrong, because intermediate code generation actually gives us a 3 address code. It gives a 3 address code, but it does not change it. So correct answer is option number C here. Next, 7th one. See, one more way I can tell you this one for this C option why it is also correct, because here in C option we also create something called give something called as actions. I mean, by looking at certain symbols, by looking at the grammar, what actions do we perform? Okay, you tell me the name in the comment. What kind of actions do we perform? What is called as that particular action? So just comment that in the comment section. Now the question number 7, they are saying the front end of the typical compiler is constituted of which of the following. See what are the phases of a compiler. One is lexical analyzer, the second phase is syntax analyzer, the third phase is semantic analyzer, the fourth phase is intermediate code generation, the fifth phase is code optimizer, seventh phase is target code generation, and in eighth we get assembly language program. Now option number 7 here, the first option that they are saying is that lexical analyzer, syntax and semantic analyzer phases. Now lexical, syntax and semantic, they are correct. These are the first 3 phases. Next they are saying lexical, semantic and code generation. Here this is wrong because before semantic we have syntax analyzer and before code generation we have intermediate code so this is correct, but before semantic analyzer we have syntax analyzer, so they missed one step here, so this is wrong. Option number C is rightly wrong because intermediate code generation is not in the first phase. Intermediate code generation comes here, which is very later. And option D is saying syntax, semantic and code optimizer. This is also wrong because they missed lexical analyzer and they missed intermediate code generation also. So correct answer is option number A. Question number 8 is saying the limitation of Banker's algorithm resources distribution are as follows. Option number A, it can handle more than 2 processes. Option number B, number of resources are static. Option number C, number of processes are static. And option D, both B and C. So let us read out something about Banker's algorithm. Where do we use Banker's algorithm actually? We use Banker's algorithm in operating system. In operating system for resource allocation to see whether we are in the safe state or not. Okay. Now I've written some text here for all of you. They are saying the Banker's algorithm has limitations when implemented. Specifically, it needs to know how much of each process could possibly request. What is the maximum number of resources can a process request? Number 2, in most systems this information is unavailable, making it impossible to implement the Banker's algorithm because they do not know. The biggest limitation is it should know what is the maximum number of resources a process can request. Okay. And making it impossible to implement the Banker's algorithm. Also, it is unrealistic to assume that number of processes is static. So number of processes they are saying is static. It is unrealistic. Okay, since in most systems the number of processes varies dynamically. Moreover, the requirements of that process will eventually release all its resources when the process terminates is sufficient for the correctness of the algorithm. However, it is not sufficient for practical system. Waiting for hours, even days for resource to be released is usually not acceptable. So number of processes are static. This is a limitation of Banker's algorithm. Number of resources are static. This is also limitation. It can handle more than 2 processes. That is correct. But these 2 are the limitations. So both B and C is the correct answer. That is option number D is the correct answer for question number 8. The question number 9 is saying parallelism is related to which of the following. See, we implement parallelism in pipelining so that we can complete more work in less time. So you can also always take an example of Henry Ford, and you can always take example of parallelism in computer architecture organization because it improves the performance of the entire system. Next, for multiprocessor system and vector system, parallelism is involved. How? I've written a small text here. Multiprocessor system is the use of 2 or more central processing units with a single computer system. Right? So we have more than one CPUs. And when we give parallelism, we can give for any program, we can give multiple instructions, and we can give the instructions which are not dependent on each other to these 2 processors, and they can execute and we can get the work done parallelly and in much faster pace. So this multiprocessor system actually uses parallelism, as well as this vector computer also uses parallelism. You can read here. I'm not explaining it because it is very easy and very intuitive. So correct answer for this question number 9 is option number D here. There is a correct answer because all these 3 concepts uses the mechanism of parallelism. Question number 10 is saying which of the following is not related to World Wide Web. Option number A is related because it is hypertext markup language. Web pages are written with hypertext markup language. Option number B is also correct because URL is the web address of the website. Option number C is wrong because UML is not used in www. It is something else. It is a different concept. And option number D is correct because HTTP is hypertext transfer protocol that is also used in World Wide Web. So correct answer here is option number C because it is not related to World Wide Web. I hope that you understood these first 10 questions.
So here we have a question from Digital in which they are asking in JK flip-flop toggle means. Okay, we have to show what toggle means in JK flip-flop. Okay, so let's look at the characteristic table of our JK flip-flop and then I will tell you what it means. Okay, we have 4 combinations: J, K, N or Qn plus 1 means the next output. Okay, so it can be 0, 0. We will check for all the combination 0, 1, 1, 0 or 1, 1. If you remember in SR flip-flop, this state was invalid, but in JK flip-flop, it is not invalid. Okay, so for 0, 0, it will be same as previous output and it is also known as latch mode. Okay, for 0, 1, it is same as SR, it is 0 and also known as reset mode. For 1, 0, it is 1 and also known as set mode. And then for 1, 1, okay, it is different from SR flip-flop. So for 1, 1, it is complement of our previous output and this state is known as toggle state. So what basically toggle means? Changing the previous output. So option D verifies it, changing the output to the opposite state. So option D is right for this. So the question is, in C, arguments are passed to functions by value or reference or value result or both A and B. From options, if we will see, we will say both value and reference because we know in C we have a choice between call by value and call by reference. But if they are asking in arguments are passed to functions by, then we will choose the default value. If we are not explicitly mentioning anything, then C uses call by value technique, not reference technique. Reference technique, yeah, definitely we can use reference by using pointers or giving addresses. We can definitely use it. You can use it, but the technique which we use by default is call by value, and not option C. Call value result. It is the combination of call by value and call by result. So yeah, it is not the right option, not reference. So both A and B, yeah, one at a moment can mark this as answer because we know of existence of both the techniques, but we will talk about the default value. So that's why our option A is right for this. So question given is, the following statements are given. Bcnf is also in 3NF. 3NF is not necessarily in Bcnf. Bcnf is stronger than 3NF. 3NF must be in Bcnf, and we have to find out the false one. Now, this is the question from databases from normalization, and we know why we use normalization techniques to remove the redundancy in our data. So let's discuss about 1 normal form, 2 normal form, 3 normal form and Bcnf. We only need up to Bcnf here. So yeah, in 1NF we make sure that our attributes must be atomic. There should not be any multi-valued or composite attributes, and when they are atomic, then only they can be in 1 normal form. Then we have 2 normal forms which says that there should not be any partial dependency. Now in 3NF it says a non-key attribute should not be giving non-key attribute. It means no non-key attributes. Also there are actually 2 statements for 3NF. If there is a dependency given as A tends to Y, then if A is super key or Y is any prime attribute, then also it is in 3 normal form. Now then comes the Bcnf, a slight modification in 3 normal form, which says that if there is dependency given as A tends to Y, then A should be super key, and that's all. It doesn't talk about the prime attribute on this side. So we can say that Bcnf is more stricter than 3NF, right? So 3NF, alright. So if you say Bcnf, it is stricter are 3NF. Alright? Alright. So Bcnf is also in 3NF. Yes, correct. Our Bcnf is satisfying all these properties, even it is stricter than all of these. 3NF is not necessarily in Bcnf. Yes, right. We have first one normal form, then two normal form, second normal form, then third normal form, and then we have Bcnf. So power goes like this. Bcnf is most strict. Okay, many times it has not been, implemented because of this only, but yeah, it is strict. 3NF is not necessarily in Bcnf. Yes, true. It is true. Okay. Bcnf is stronger than 3NF. Yes, true. 3NF must be in Bcnf. Not necessary, no? These two statements are contradictory. And it is not necessary that 3 normal form must be in Bcnf. So option D is wrong. So we have to pick out the false one. So option D is right. So here we have question from B plus trees, and we have few options. We have to pick out the incorrect one again. So data pointers can be stored at any level of the tree. Data pointers can be stored only at the leaf nodes of a tree. The searching time is same for any key, and the leaf nodes contain the search field and the data pointer. And we have to pick the incorrect one. Yeah, there is slightly difference between B trees and B plus trees, and sometimes it does create confusion. In B trees, we distribute the entire index record all over the tree. That is, at every node we have key and data pointers. Okay, but in B plus tree the structure is slightly different. At the root or internal node we have our node pointer, then key, our node pointer, and then key, our node pointer, and then our key, and it goes like this. And it is same for all the internal nodes, and only at the leaf nodes we have what? Key, and then along with that we have data pointer. Okay, so it depends on the structure also. Key and data pointer, key and data pointer. If you will see, it is also different in terms of defining the leaf nodes. Here we do not have node pointers at the leaves, only at the root or internal nodes we have our node pointers. These are node pointers, and this is key pointer, and these are our record pointer, or we say here data pointers. Okay, so in leaf nodes only we have our data pointers, and these key node pointers and key we store in internal nodes, in leaf, and in root also. Okay, so let's check out the options. Data pointers can be stored at any level of the tree. No, we just have seen that data pointers can only be stored at the leaves. So option A is wrong. Data pointers can be stored only at the leaf nodes of the tree. Yes, true. We have seen just now. The searching time is same for any key. Yes, this statement is true. The searching time is same because we have reduced, actually in B and B plus tree, the difference is the depth is been reduced in B plus trees because we are maintaining our data records only at the leaf, and again in B plus trees the breadth is increased while the height is decreased. Okay, so it makes our searching easy, and therefore the searching time for any key is also same because we are maintaining index for all the records. This one is also pointing to this one and this one, so it is same for all the keys, for keys only. The leaf nodes contain the search field and data pointer. Yes, it contains key and data pointer. Okay, not the node pointer. Node pointers are only at the internal nodes or your root node. So option D is also right. So which option is right? We have to pick out the incorrect one. So option A is incorrect. So we have our question as SSL is designed to provide security and compression services to data generated from application layer, security and compression services to the data generated from the network layer, or security and compression to data generated from physical layer, or the security and compression to data generated from the transport layer. Now first, what is SSL? SSL is Secure Socket Layer Protocol. It is a computer networking protocol for securing connections between network application client and servers over an insecure network like internet. Okay, internet is considered as insecure medium. Okay, or we can also say is that it is for establishing encrypted links between a web server and a browser in an online communication. Okay, so basically SSL is a protocol, security protocol, which is maintained by the TCP. Okay, in TCP, when we study about the network security in TCP, then we study about the SSL. And so these B and C options are clearly wrong here, not from the network layer or the physical layer. Now there is confusion between the application layer and the transport layer. Now we have to read the options very carefully. Okay, security and compression services to the data generated from application layer, or security and compression to data generated from the transport layer. Okay, let me just give you architecture of SSL. Then you will clearly understand what I want to say. Architecture of SSL. It goes like this. We have our application layer, and then we have our SSL layer. Okay, this is application layer, then our SSL, secure socket layer, then our TCP, then IP, or then your rest of the layers. You can say here we maintain HTTP, FTP, or our FTP, or our SMTP, right? Then our SSL, our secure net security protocol, then transport layer, and then our IP, internet protocol. So SSL is there in between application layer and the TCP layer. Okay, we can see that. So read the options carefully. SSL is designed to provide security and compression services to data generated from application layer. So this option is right, not from the transport layer. Our data goes like this, na? From application layer to then TCP, and then IP, and then again from IP TCP to AL of the destination. But our data from the application layer then goes to TCP. So our data, so option A is right, not option D. Okay, SSL is a standard security protocol for establishing encrypted links between web server and a browser. Okay, so they work in application layer. Okay, so we are actually securing our data from data coming from the application layer, not from the transport layer. So option A is clearly right here. So our question is, data mining is related to knowledge discovery, classification, clustering, or all of the above. So let's see. First, let's understand what data mining is. Data mining is defined as extracting the information from huge set of data, or we can say that data mining is mining the knowledge from data, huge set of data basically. So let's see if these options justify this or not. Now, knowledge discovery, it is just a synonym for data mining, discovering the knowledge from the data we already have. Now next is classification. We know that classification is a technique in data mining which is used to classify our data. Now, for example, like in a bank officer would like to know the potential customers he can give loan. I mean, the customers in which there is less chances of risk. So what he will do, he will classify the customers on the basis of their risk, their background, how much they are earning, and all these things. So it is basically classifying the data. So yeah, it is a part of data mining. We do use this technique. Now, third is clustering. It is a very well-known technique in data mining. It is a it is grouping of a particular set of objects based on their characteristics and aggregating them according to their similarities. It is a very well-known technique and we know this. And so all these three options are related to data mining, so answer would be D. So here we have question as how many Hamiltonian circuits are there in a complete graph with n vertices? It is a complete graph with n vertices. Okay. So what is a Hamiltonian circuit? A Hamiltonian circuit is one in which we have to traverse the graph, and in that we can visit each node or each vertex exactly once and have to reach back at the same node from where we have begun it. Okay. So we have to see how many Hamiltonian circuit exist for complete graphs for 1, 2, 3 and so on. So there are two strategies to solve these kind of question. The first strategy is this is a standard example, so you see the derivation, how it is being solved and how the answer is being derived. Okay, and second way is you take examples like for 3 vertices, 4 vertices and see which option is right. We will solve by both the ways. So let's see. First, let's see how it is been derived. So let's understand it. Here we are talking about the complete graph. So every pair of vertices is connected by the edges. Okay, and we can pick in any order of the vertices we want to visit them. Okay, but we have to be careful about the cycles. They are n factorial ordering of the vertices. Ordering of vertices, n factorial ordering of vertices. We can begin from anywhere, but like for example it is k3, right? Complete graph with 3 vertices. So if I begin from 1 and then 2 and then 3 and have to reach again, then 1 2 3, the same graph we will get. If I will begin with 2, then I can go to 1 and then like this, from 2 to 1 and then 3 and then from 3 to again 1. So same graph will be given. If I begin from 3 and then 1 and then 2, so it is same. These two are same. So we have to deduct these also because there could be cycles. So we do not want the redundancy. We want the unique ones. Okay. So we have to reduce them also. So there are n factorial ordering of the vertices, and then we have to divide it by 2n, since each cycle can be written as permutation in 2n ways, depending on which of the n vertices you start at. Okay, you can start irrespectively, but have to check the cycles and which of the 2 directions you traverse your cycle in. Like from here you have 2 directions from which direction you want to go. Okay, so that's why this. And this can be written as n minus 1 factorial by 2. So this is one of the way you can solve your question. This is a standard question, so you can remember it. Okay, and the derivation is also easy. N factorial ways to for the ordering of vertices, and then there is redundancies because we can also have cycles, so we have to divide it by 2n permutations. There are 2n permutations for that, and so our answer would be D. But there is an easy way to solve these kind of questions, like if this idea do not strike during the exam in your mind. So there is another way, a cheat way. We can take the examples like let's say for example K3, a complete graph with 3 vertices. Okay, A, B and C. Okay, there is only one Hamiltonian circuit for this. No matter from where you start, from A or B or C, you will get the same. So for this the answer is 1. Okay, for K3 answer is 1. So formula we have derived is n minus 1 factorial by 2. So here put the value of n equals to 3. So we will get what? 2 factorial by 2, which is equals to 1. So yeah, it is justifying. Now let's check for example K4, a graph with 4 vertices, a complete graph basically. So it is not complete yet. Now it is a complete graph. Let's see how many Hamiltonian circuits we can make. So one way is this. Okay, this is first way. Second, I can begin from here, then I can go here, third vertex, fourth vertex, and then go back to the starting vertex. Third way I can make is begin from here again, and then this one, and then this one, and then going back to the starting vertex. There's no other possible way I can design. You can try. So for K4 it is n minus 1 factorial by 2, n value has 4, so it will be 3 factorial by 2, so it is 3 cross 2 by 2, so it is 3. So yes, our answer is 3. So option D is right here again. So this is a theoretical question, and let's read about it. Which of the following is the process by which user privileges are ascertained? Now we have given 4 options, and there's confusion between these 3: authorization, authentication, and access control. So there is minor difference between all these 3, and we have to see which one is the process by which user privileges are ascertained. Okay, so in this I'm going to give points and difference between these, so listen carefully. Authorization is the process by which user privileges are ascertained. So authorization is the right option. It is right. Okay, now what is authentication? It is the process by which a user's identity is checked. Okay, now in access control, it is the process by which the user's access to physical data in application is limited based on his privileges. So it deals with the privileges given to the user. Authentication, in authentication we give the ID and password and all these things, and we check on the basis of that. And authorization, in this the privileges are ascertained. So option A is clearly right. So our question is, linked lists are not suitable data structures for which of the following problems? Insertion sort, polynomial multiplication, radix sort, or binary search. Okay, so we know how linked lists are maintained. We have a node, and for the first node we have a head pointer, then we have data over here, and then here we have node pointer which pointed to the next node, and it goes like this. All right, so the linked list have only sequential access. Sequential access means if I want to access this particular node, I have to begin from the first node, then here, and then here. I cannot directly access it. So it is sequential access. Okay, if we'll see all the problems, let's look at the binary search problem. What is binary search problem? In this, when elements are stored, okay, and we have the value which I want to search, then first I choose a median randomly, and then I compare the value of this search key with this, and if it is smaller then I go to this side, and then if it is bigger then this side. So we do this iteratively. If it is smaller, then I will see that my range is here, and then again I will choose the median value, and then again smaller or bigger, and then again the median value. So it is iterative process. If we look clearly, we can clearly see that in binary search we are randomly accessing the median element. Okay, and which is not possible in a linked list. So binary search is not suitable for the linked list. If we look at the other options, we can easily implement them using linked list. Okay, you can try implementing them. So for this, binary search is the right option. So here we have question from networking, which says, which of the protocol uses both TCP and UDP? So let's check out the options and see which protocol they use. So first option is FTP, a file transfer protocol. It uses TCP and never UDP. Okay, you can get confused between your TFTP and FTP. It is trivial file transfer protocol, and it uses UDP only, and FTP uses TCP only and never UDP. Next we have SMTP. SMTP also uses TCP. Okay, now next we have Telnet. Telnet also uses TCP and at port number 23. Now DNS. So it's not the option, it's not the option because all these three uses TCP. DNS is obviously the right option, and DNS uses both TCP and UDP. Now it uses UDP when the information is small, okay, and it uses TCP when the information size is more than 512 bytes. Okay, so DNS is the right option, which uses both TCP and UDP. So here we have a question from networking. They are asking, when you issue ping command, what protocol are you using? DNS, DHCP, ICMP or ARP? Okay, so let's check out the options and then I'll tell you which one is correct answer. Okay, so first one is DNS. DNS is domain name server. No, this is not the answer because we know how DNS is used and how it works. It is used to resolve the names. Like when you use your phone book, okay, you know the name but you don't know the person's phone number. Okay, so you use your phone book. Same way, when we type a particular website in our computer, we type the name which is very user friendly to us but not for the machine. So what DNS do is convert that human readable format into the something machine can read, like 123.30 and something like that. Okay, so this is not the option obviously. Second option is DHCP. DHCP is Dynamic Host Control Protocol. It is used to dynamically assign IP from pool of IPs. So this is also not the right option. Now third one is ICMP, Internet Control Message Protocol. Okay, now ping is a command prompt command. Okay, it is used to check the ability of the source PC to reach the destination. Okay, what it does is it uses the ICMP to create the echo request and we wait for the response. So yes, ICMP is the right option. Okay, what ICMP does is ICMP along with ping, it generates a echo request to the receiver, and if our receiver is reachable and it do not fall under any congestion, then it responds. Then we get a reply. Okay, it is echo request, and what we get in reply, we get echo. Okay, so and that is how we can know that our destination is reachable. Okay, now the two important thing for using this is for using ping command is how many responses we get and how long it takes to get the response. It tells about a lot of things, like if our destination is free and about the congestion of the path and lot of other things. So ICMP, yes, this is the right option. The fourth one is ARP. It is Address Resolution Protocol. It is used to get the MAC address if we know the IP address. So this is not right. So our option C is right for this. Okay, so here we have question as shadow paging techniques maintain 2 page tables, 3 page tables, 4 page tables or 5 page tables. Now shadow paging is a technique which is used in transaction, and we know there are 4 properties in the transaction that we have to maintain: atomicity, consistency, isolation and durability. Using shadow paging technique, we basically ensure that these 2 properties are well maintained, that is atomicity and durability. And now let's see how it is being maintained and what is shadow paging technique basically. So in shadow paging technique, what we do is, suppose this is my database, my stable database. Okay, and I will have a database pointer which will be pointing to my database. Okay, perfect. Now let's suppose I have some transaction going on. So what I will do is I will create a database separately for it, which is known as shadow. It will be the exact copy of my database, so it is known as shadow database. And what we do is, during the transaction, I will be using only my shadow database, not the actual database during my transaction. So all the updates that I will be doing, all will be done in the shadow database. Now, why we do it and what are the benefits of it? Now just suppose you are in the middle of transaction and some failure occur. In that case, what we do is atomicity. What it means that either it should be fail or success. There should not be any middle state. I mean, either you complete your transaction and it is successful, you make all the changes, or if it stop in between, then completely fail it. Okay, like nothing has happened. So in this, what we do, we maintain a shadow database, and if anything happen wrong, something wrong happened, then we have nothing to lose. We will just cancel it, and we have already our databases. But if everything goes right, I have done my transaction and there was no problem, then what I will do is I will point this database pointer now to this shadow database, because this is the updated one. Okay, and what I will do, I will remove the old database. I don't need this because I want the updated database. Okay, and we can clearly see that we are maintaining 2 page tables here. No need of 3, 4 or 5. Okay. So here we have a question which says round robin scheduling behaves like FCFS scheduling when option A says when the time slice is less than the average CPU burst, or the time slice is less than the smallest CPU burst, or the time slice is greater than the CPU average CPU burst, or D option, the time slice is greater than the largest CPU burst. Okay, what is round robin scheduling? In this we assign a time quantum. Okay, and after the finishing of our time quantum, it's a particular time we give, and after finishing of the time quantum, we switch between the processes. I mean, for this duration only we can allow a process to execute, and then we reschedule it. But we are saying that when it can behave like FCFS. So let me just give an example, and you will see when is the time when our round robin scheduling can act like FCFS. Okay, so let's take example. Suppose we have 3 processes, P1, P2 and P3. Let's assume their arrival time to be 1, 2 or 3. P1 occur first, then P2 and then P3. Let's suppose their burst time to be 7 or 11 or 4. Okay, now let's assume I assign my time quantum to be 15. Okay, so after every 15 I will switch between the processes. Now the Gantt chart will look like, first the P1 came, it will get 15 seconds, but it needs only 7. Okay, so after finishing up to from 1 to 8 it will go, or you can assume from 0, no need, from 1 to 8 it will go, and then after that it will go out of our running process and will go back to its state, whether it, because its requirement for the CPU is now done. Now P2 will come and it will be assigned then for 11 seconds, so it will be 19 up to 19, and then it will go out, and then P3 will come up to 23. Okay, so if we will see, it is exactly behaving like FCFS, isn't it? Because the time quantum is too big, that the processes, their burst time is smaller than the time quantum, so they are coming on the basis of their arrival time, they're completing it and going out, and then the next process is coming. So when it is behaving like exactly as FCFS, when the time quantum is greater than or combine all the CPU bursts, means it is greater than the burst time of all the individual processes. So option D satisfy it perfectly, that the time slice is greater than the largest CPU burst. So here we have a question from software engineering in which they are asking verification and validation are components of software documentation, data quality management, software quality assurance, or the testing. Okay, so let's first understand what is verification. So verification, mainly it is the process of checking whether our built software is meeting the requirement. Okay, so verification basically deals with the software. Now validation is the process which checks with the whether the customer's need is fulfilled or not. Okay, the promises which we have made to the customer, whether they are fulfilled or not. So verification validation is, you can say, is a complete the complete set which asks whether the built software is fulfilling our software need as well as our customers need. So let's see, it comes under what component. Okay, now software documentation, we know it is the documentation in which we follow the SRS, the design which we are going to use, the algorithm, and the kind of technique I'm going to use. So definitely verification validation does not comes under it. Okay, next we have total quality management. It is one of the important process in which we not only deal with the coding and testing and basically with the technical terms, but also with like teamwork, okay, training. Like if you are introducing a new software in your company, you are building a completely new software for the customer, so to train your employees according to that, and leadership is also a part. So in this, it is ensuring that not only you must be good with the technical terms, but also whether you are positive enough towards completing your software. It also includes leadership, ethics, improvisation, design, planning, brainstorming sessions. It all comes under total quality management. Now next we have software quality assurance. It ensures that the developed software meets and complies with the designed quality specification. Means I have given a design to the customer that I'm going to complete my software like this. So this is the technique which says that we are going to fulfill the need of our customer and the software. So from the wording itself, we are verifying that these two are the components of our software quality assurance. Okay, now let's is testing. We know testing means testing our software or the components of it. We have many testing techniques like black box testing, white box testing, regression, and all these testings to check whether the particular software is meeting the requirements. We can also do the real time or the simulation. So there are a lot of techniques, but it is not part of verification validations are not part of testing. Okay. So here we have a beautiful question from set theory and algebra, which is saying the number of binary relations on a set with p elements is. So it's a binary relation. So in a binary relation, 2 elements are chosen from the set. Okay, because it is a binary relation, so 2 elements will be chosen from the set. So with the p elements, how many pairings are possible? P power 2, obviously. Pairings are possible, right? Why? Because we have p elements and it is a binary relation, so p power 2 pairings are possible with that. Now a relation can be a subset of these p power 2 pairings, right? Relation can be a subset of these pairing. So what will be that? 2 p power 2. Okay, so C option. So here we have a question. Which of the following statement is not true? A tree with n vertices has n-1 edges, or any connected graph with n vertices and n-1 edges is a tree. A tree with n vertices has n edges, or a graph is a tree if and only if it is minimally connected. We have to find which one is not true. Okay, read the statements always very carefully. So the easiest way to solve these kind of question is taking an example and verifying the points along with it. So you can have your tree at any way you want. Okay, I am having it this way because for me it is easy to visualize it this way. So here I have how many vertices? 1, 2, 3, 4, 5, 6. 6. And how many edges I have? 1, 2, 3, 4, 5, right? I can increase the number, like I can have this. So then how many vertices will be there? Then there will be 7 vertices and 6 edges. Okay, so I can have anything I want. So take the minimal example, it will be easy. Now let's come to our options and see whether it is verifying this or not. Okay, a tree with n vertices has n minus 1 edges. Yes, it is true. We have just seen if there are 6 vertices, then we have n minus 1 edges. So option A is right. Now any connected graph with n vertices and n minus 1 edges is a tree, right? We have just seen. So option B is also right. Now C option says a tree with n vertices has n edges. If there are n vertices, we have seen for being a tree it should be n minus 1, but they are saying n edges. Now let's take a different example. I can also show this way, but I'm just trying every possible thing. Okay, so here I have how many vertices? 1, 2, 3, 4, 5. 5 vertices, and how many edges I have right now? 1, 2, 3, 4. It is perfectly a tree. But if I'll have n edges, I'll just introduce one more edge. Now what it is? It is a cycle. Now it is 5. So what it is? It is forming a cycle, and a tree is a graph which never has cycle in it. So this option is clearly wrong. So this is our option, because we have to pick which one is not true. Next option, a graph is a tree if and only if it is minimally connected. Obviously this is the right this is also right. In a graph, a tree is always minimally connected. That's why it has many search properties or many things, because we don't need to point everything with the same node. If I want to reach here, I know how to access this one. I don't need to maintain a direct pointer to it. Okay, there are defined ways I can use my trees. There are many applications and many implementation we do through trees, and there should not be any cycle. So our option D is also right. So option C is the right answer for this question, because we have to pick the wrong. So here we have a question which says, which of the following statements do not satisfy the principle of structured programming? Options are the use of loop statements, the use of goto statements, the use of sequential program statements, or the use of if then else statements. So let's see what is a structured programming. In structured programming, what we basically do is we divide our program into smaller structures, and then we solve them and pass control to other structures. Vice versa, we can do that. Okay. So the main theorem in the structured programming entitles like sequences, selection statements, iterations, and recursions. Okay, so basically we are just defining the structures or routines, and we perform our tasks. They can be sequentials, or we can make small iterations on it, recursions on it, and the selection statements on it. So one of the best example which follow the structure programming method is our C language. Okay, C is a structured programming language. C or Pascal and our Algol also follow structured programming. So let's come to the options. Option A says it uses the loop statements. Yes, it does uses the loop statements. The option B, let's come to it later. So next is the use of sequential program statements. Yes, it is right. If I'm following a routine, I'm using it sequentially. Okay. Now the use of if then else statement. Yes, we are using selection here. So it is following all the theorems. Now why not goto statement? Goto is actually an unconditional statement, and it can jump out of the scope of particular structure. So that's why it does not come under the structured programming. So B is the only option which do not satisfy the principle of structured programming. So B is the right option for this. So here is a basic question. It says a base class is inherited by a derived class, an inline function, or a constructor, or none of the above. So inheritance is a property by which we can inherit the properties of other classes also. Okay, so there are two things: a base class, or we can also call it as superclass, and other thing is derived class or a subclass. Okay, now derived class or subclass is one which inherited the properties from other classes. Okay, and base class or superclass is the one whose properties are being inherited. So basically it goes like this. So base class, the derived class inherit the properties from the base class. So a base class is inherited by a derived class. Is clearly option A is right for this. Inline functions are used to increase the runtime. What is the difference? Like, we make function. Why do we make functions? So that when in future I want to use them, I can again use them by giving just name of the function and passing arguments in it. Inline function is better implementation. In this, what we do is we implement a function, okay, inside a class, and we give it a name. So when a compiler sees it, it automatically runs it and it becomes faster during the runtime. Constructor, it is totally different concept. It is used to initialize our objects. So option A is right for this. So here we have a question which says the operation of a relation X produces Y such that Y contains only selected attributes of X. Such an operation is either projection or intersection, union or difference. Okay, so this is the question from databases. We will see what it is trying to say, that we had X. Okay, X is a relation. There were some attributes. After applying some operations on it, we get Y, and Y has only selected attributes. Like, suppose it had previously it had ABC and now it has only AB. So out of all these options, which operation could be the one which can lead to this kind of outputs? Okay, so let's see. I'll tell you the shortcut also, how to find answer for these kind of questions. So first let's see the options. The first one is saying projection. What is projection? Projection is selecting the attributes. Like this, I can, like, suppose I have my relational database which contains the values as, suppose Alice age 5 or Bob aged 7, I say, and if I apply my projection on age only, I want to know about the age I have, so I'll get the output as 5 and 7. So it is only giving me 5 and 7. So yeah, projection is the right option because I can drop my attribute values over here. Intersection, it gives the intersection values, so it is not the right answer. Union, it will add the values, not drop the values, so clearly it is not an option. Difference, if I say A minus B, what is it say? It says all the attributes, all the values which are present in A but which are not in B. So difference is also not the right option. Okay, now the shortcut trick for this is projection is the only operation which is working on the attributes itself. Okay, on attributes, it can select attributes, it can drop the attributes it wants, it can, okay. So that's why projection is the right answer. Intersection, union and difference, they work on the values, these tuples. They cannot drop, they do not have the right to drop the values of our attributes. Okay, only projection can do that. That's why these three options are wrong and projection is right for this. So here we have a question from normalization. It is saying that 2NF, a second normal form, is based on partial dependency, transitive dependency, full functional dependency or non-trivial functional dependency. Okay, so let me just give you an example. It will be clear for you then. So suppose I have a relational database which has the attribute A, B, C, D, and I've got my candidate key as AB. Okay, two attributes combined give me my candidate key. Now they are asking 2NF is based on partial dependency. Now first, let me tell you what is partial dependency. Partial dependency means if AB combined our candidate key, then suppose our B gives C. AB is candidate key, so AB can give C or D, right? But here B is breaking the partnership and giving dependency on its own. So this is partial dependency. And when a relation gives partial dependency, it is not in 2 normal form, and 2NF is not based on this. Okay, now next option is transitive dependency. It is not a part of this. It comes under the 3rd normal form. According to this, it says that if A gives B and B gives C, which tells that A also gives C. And our 2nd normal form is not based on transitive dependencies also. Now 3rd one is saying full functional dependency. Full functional dependency means this. When our candidate key only candidate key give our other attributes, okay, and they do not break the partnership. If A, B combined our candidate key, they should not break the partnership, and they combine should give other attributes. Then it is full functional dependency, and yes, our 2nd normal form is based on full functional dependency. Now 4th option says non-trivial functional dependency. It is quite trivial thing they have asked. So what is trivial dependency? Like suppose A gives B is given and B is a subset of A. It is obviously automatically implied that B is derived from A because B is a subset of A. Then it is known as trivial functional dependency. But they are saying every non-trivial functional dependency comes under 2NF. No, it is not right. If according to this, if our C gives D, okay, or our B gives C, then it also comes under 2nd normal form. But we have just seen that in 2 normal form, what we say, there should be full functional dependency. And on what? On our candidate keys. And there should not be any breaking of our partnership. So option C is the right option for this. So here we have a question which says, which of the following traversal techniques lists the nodes of binary search tree in ascending order? We know we have 3 techniques: traversal techniques, post order, in order, and pre-order. Okay, and they are asking which of the techniques traverse the list in ascending order. Okay, one of the best way to solve this kind of question is by solving an example, calculating its pre-order, in order, and post order, and then seeing which one gives the ascending order. So let me give you an example. It will be clear for you then. So you know the property of BST. If just suppose if this is my root, then on the right of it should be greater than 7, and on its left side all nodes must have lesser value than 7. So I am saying 5, it is lesser than this, and on this side I'm saying, let's suppose I'm saying 9. Okay, now again on its right it should be smaller than this one, so let's say 2. Okay, and on its left side it should be greater than this one but should be smaller than this one, so let's say I'm saying 6. Okay, we must always check whether it is following the BST properties or not. So it should be greater than 7 and less than 9, so let's suppose it is 8, and here let's say 11. Right, so we will traverse our list in all these 3 orders and we will check. So first let's check what pre-order gives. The pre-order of this graph will be what? 7. This is how we traverse, right? From top to down and left to right. So what is my pre-order? It is 7. Then I'm visiting 5, then 2, then I'm visiting 6, then I have already visited 7, then new node is 9, then 8, and then 11. So this is my pre-order. Let's check my next in order. So in order means when I visit the node for the second time. So for the first time No, it will make my traversal easy. Okay, so 2 for the first time, second time, so 2, then 5, then second time 6, then second time 7. You know how to calculate the in order, so I'm doing the same way, it is easy. Then 8, and then it's 9, and then 11. So I can see that it is actually in order, which is traversing my list in ascending order. So in order is the right answer. So let's traverse it post order also. So it will be what? When I visit a node for the last time, so 2 is visited last time, so it's 2, then 6, and then 5 is visited last time, then 5, 7 is visited second time, so it's not the time to write it. Now 8 is visited last time, then 8, then 11 is visited last time, then 9 is visited last time, and then in the end 7. So this is our post order. So out of all, we have picked our right answer. So in order is the one which gives the traversal in ascending. So here we have a question which asks, telephone network works in single mode transmission, half duplex mode transmission, full duplex mode transmission, or arbitrary mode transmission. Now we all know when we talk in a telephone, then both the parties can communicate simultaneously. Like suppose if we have a sender here and a receiver, two people, they can simultaneously exchange the information, and that's why it is known as full duplex communication or transmission. So the telephone network, the answer C is correct. What is single mode? When only one party can send the data. Half duplex means both the parties can send, but only one at a time, like walkie-talkie. Arbitrary mode transmission, it is just mixed, like randomly if S is sending data, R can send data, but it is not always possible. It is not the case at all. So full duplex perfectly satisfy for telephone network. So here the question is, in TCP IP protocol suite, layers are arranged from bottom to up as follows. Okay, so we have to go from like physical layer, then data link layer, and all these. So they are asking how they are arranged. We have two models, OSI model and TCP IP model. They are talking about TCP IP. In this, sessional layer and presentation layer are not present. Okay, so for TCP it goes like, first we have physical layer, then we have data link layer, then we have network layer, then we have what? Transport layer, and then application layer. So which of the options satisfy? P, D, and T, and E. So C option is right for this. So here we have question from compilers. They are asking, tokens are identified during lexical analysis, syntax analysis, semantic analysis, or the code optimization. It is very easy question. We know what are tokens. Everything defined in C language, whether it is a bracket or words or everything, they are known as tokens. And which one is the first phase? So obviously if they are the very first step, they will be identified as soon as possible. So lexical phase. In syntax phase, we check for the syntaxes using grammars. Then we have semantic. In this, we make the parse tree and then check the semantics. Code optimization is totally different. This we use 3 address registers and all these things. Okay. So tokens, just think of it like I have a print statement. Printf hello. So how many tokens are there? Number of tokens here are 1, 1, 2. Under these double quotes, everything is considered as 1. So it's 3, this closing brace is 4 and 5. So we have number of tokens as 5. Okay, so yeah, this is the answer. In lexical analysis phase, white spaces and comments are also removed, and also identifying token is done at this phase. So here we have a question which asks, in function point analysis, number of complexity adjustment factors are 10, 20, 14 or 12. Now what is function point analysis? It measures the functionality from user's point of view. It measures the functionality from user's point of view. Like when you give your product to the user, then from user's point of view, we will check whether he is getting what he asked for. The end user do not care about the line of code, algorithm that you are using and all these things. All he cares about is when he give you your software, like what is his demand, then he care about whether your software is giving all those functions or not. Doesn't care about the line of code and all these things. Okay, so they are asking number of complexity adjustment. There are 14 actually, number of complexity adjustment factors, which checks the overall analysis of our software. Okay, so they are asking for the number of complexity adjustment factors, so it will be 14. So here we have a question, why cyclomatic complexity is given by. Okay, and we have a few options here. So first of all, why cyclomatic complexity is done? Cyclomatic complexity is done to check the complexity of our program. Okay, it is also known as structural complexity also. Okay, and it is done to check whether all the parts of the code are executed at least once. Okay, so cyclomatic complexity is calculated for the flow graphs, like when we use loop statements or if and else statements, there we form a flow graph from it, and then on the basis of that we make parts and components and predicate nodes, and from that we try to calculate the cyclomatic complexity of our program. Okay, so here I'm going to give one example. On the basis of that, we will check whether these formulas are correct or not. Okay, so let's consider I have an example this. Or this, you know, all these are flow graphs. We are just giving the flow. Let me make it more complex so that when they will ask easy question, you will be easy. It will be easy for you to calculate. Okay. So I think this is good example to give. Okay. Now first one is saying Vg is equals to E minus N plus 2. Here E indicates the number of edges. Okay. And N indicates the number of vertices. Okay. So here if I'll see how many edges are there, 1, 2, 3, 4, 5, 6 and 7. So E is equals to 7. Okay. And how many V's are there? I mean N. You can also say N or V. So how many N are there? 1, 2, 3, 4, 5, 6. 6. Okay. So we have, they are saying the formula for the first one. Vg is equals to E minus N plus 2. So here we are getting 7 minus 6 is 1 plus 2 equals to 3. Okay, so we are getting 3 cyclomatic complexity from the first formula. Let's check for the second one. The second one says it is Vg is equals to, we can say it is pi or p. Okay, pi or p. It is predicate node, we can say. Okay, what is predicate node? Which has the shortcut is which has 2 outgoing edges. 2 outgoing edges means it has either true or false, like this one, true or false. So it has 2 statements, right? So this one is our predicate node. So how many predicate nodes are there? This one is predicate node first. It has 2 outgoing edges. This one is predicate node. It has two outgoing edges. This one is not predicate node because it has only one outgoing edge. This one is incoming edge. And this one is also not predicate node because it has one incoming edge and one outgoing edge. So how many? We got predicate nodes 2. So it's 2 plus 1 equals to 3. So we are getting same answer as this one. Now let's check the next one. The third one. It says the number of regions. Number of regions. Now what are number of regions? Like this. This is a region. It is enclosed. Okay. So it is a region. So it is first region. This is open, right? Everything. So this is second region overall. Okay. Is there any enclosed region? Yes. This one is here. So 3. So 3. We are getting same answers for all these 3. It means that all these 3 formulas are used to calculate our cyclomatic complexity. So our answer would be D, all of the above. All 3 are used to measure the cyclomatic complexity. So here we have a basic question which says if the base register holds 300040 and the limit register is 120900, then the program can legally access, and they have given few options to us. Alright, so let's check it. Now when we store some information, okay, like suppose we have this sort of information stored sequentially, and they are saying that suppose here, okay, they are saying the base register from where the program actually begins is storing 300040, and they have also given the limit register. Limit register tells up to which this part only our program can access the memory, particular memory, okay, not more than that. So let's suppose I am giving limit up to here, so it is given as 120900. Alright, so they are saying it can legally access. So we will check the up to which memory it can access. Okay, so base, in this the value for base will never change. Okay, so it will be calculated as it is, and for this it is beginning from 40, so we will reduce one value from it. We know why. So it will be 120899 up to this limit, right? But and we are beginning from 40, so it will go up to 899. So it will be 9. We will add because we want to find the amount it can legally access. Okay, this particular program, the memory it can legally access. So it will be 9, 3, 9, 0, 2 and 4. It's 420939. So option matches with this only. It can access from here up to here only, inclusive, right? This one is saying all addresses from 300412. This is what they are doing is they are changing the base, but we are not allowed to change the base because they have already given it. Okay, and we calculate from the base only. So base will never be changed, and up to the limit we will reduce 1 because we are starting from the base. So this is the right option for this option. So this is the question. In this they have given us a grammar, and then they have asked us to find the first of A, okay, and first of B, and then find the intersection between these two. In this question there is slightly mistake. Actually, in place of C they want to make it as terminal small c. Okay, so just correct it. This is small c. It is a terminal symbol, okay, because it is in one of the option, and you will see why I'm saying this. Okay, so let's find out the first of these two non-terminal symbols. We know how to find the first. So first of A will be calculated as what? It will be C, terminal C and A. And if we find for B, it will be C and B. Now they have asked for the intersection of first of A and first of B, which is C, obviously. So answer is C. So option D matches with it. There sometimes happens that they give the some printing errors, so don't worry about it. Marks will be granted for all the students. If not, then also we can use a common sense that it is obviously a terminal symbol C, and that is the only way we can get this answer as C. Hello. So here we have a question from Automata, and they have given us some regular expression over the alphabet 0, 1, and it is 0 star 1 0 star 1 0 star 1 0, and they are asking what it denotes. All binary strings possessing exactly 3 ones, all the non-empty binary strings, or all the binary strings including empty string, or all the binary strings possessing more than 2 ones. Okay, so in this kind of question they try to confuse you with the words. So when these kind of questions come, you have to read each and option very carefully and have to match with the given regular expression. Okay, so first try to analyze this regular expression. In this, it can have any number of 0 and then 1, any number of zeros or just epsilon and then 1, any number of zeros, then 1 and 0. Okay, so what the first option says, it says all the binary strings possessing exactly 3 ones. Yes, it is right, exactly 3 ones, not less than 3, not more than 3. So yeah, option A seems right at the moment. Now, all the non-empty binary strings, all the non-empty binary strings, but have to be exact na. According to this, even if I write 1 0, it is non-empty, this will also be accepted. But if you look at the regular expression, this is not accepted, so option B is wrong. Okay, now look at the third option, all the binary strings including empty strings. Yeah, okay, fine. Then again, same example, there has to be 3 ones. They are not focusing much on these factors, and it is saying all the binary strings including empty strings. Including empty strings, no, it is not right, because compulsory we need to have 1 1 1 and 0. Okay, this and this, so it has to be there, and they are saying including empty strings. So because of this statement is also wrong. Now it is saying all the binary strings possessing more than 2 ones. This is also not right. Why? Because according to that, if I do this, then also it will be accepted by our regular expression, because they are talking that only more than 2 ones. I can have any number of ones, but no, this is not right. So option A is right for this. So here we have a question from software engineering, which is saying mutation testing is related to fault seeding, functional testing, genetic algorithm, or fault cracking. Now let's first talk about what is mutation testing. Mutation testing is one in which we intentionally add few bugs in our built software. Okay, what we do is we make intentionally few bugs or some error code, we intentionally add them in our code, and then we check it against the test cases. If our software is able to rectify those errors, then it is fine, otherwise not, then we again recode it. Okay, and we know one of the most famous mutation testing is fault seeding. In this we add small codes of few bugs and check against mutation testing. So option A is the right answer for this. So here we have a question, program volume of a software product is, and we have given few options, and this is used to find the complexity of our software. There is a metric and so many parameters through which we find the complexity of our software, like vocabulary, testing time, size, difficulty, errors, and efforts, and all this thing. And volume is one part of it. And for the program volume, we know how to calculate it. It is calculated as V is equals to size into log base 2 vocabulary. Alright, in which size is calculated as n1 plus n2. Now, where n1 represent the occurrence of operators, okay, and n2 represent the occurrence of operands, and n1 is occurrence of operators. Alright, then we have vocabulary, it is calculated as n1 plus n2, where n1 represents the number of unique operators, unique, not duplicate, number of unique operators, and n2 as number of unique operands. Okay, so in one of the options they are asking how this is calculated. We have derived the formula. This can also be represented as V is equals to, size is also defined as, this one is written as what? Capital N. Alright, and this one can be written as small n. Small n. So if you put in this formula, it will be size into log base 2 small n, which matches with our first option. So this is the right answer. So here we have a question from encryption. The question says the general Caesar cipher substitution function for encryption is given by, the 4 options are given, and where P is plain text letter and K takes on a value in range from 1 to 25. So we know Caesar cipher encryption method is was the previous one, okay? Before this one, Caesar cipher substitution function was also known as shift cipher. Like suppose for letter C, example I'm giving, for letter C, alphabet C, I'm saying if it is third, let's suppose I'm adding 3 to it, then after A, B, C, it is on third place, I am adding 3 to it, so D, E, F, so C will be represented as F. So this is shift cipher substitution, but this is one of the weakest form of encryption, because one can guess it or by checking the frequency and all these things, so it was quite weak. So what he does is he introduced a function to it, and through that he saw that the results are better now. So what he does is he calculated as the text, the cipher text, the final output that we will get by making the our plain text letter, whatever we are using, by adding it to some random number that we will choose, and here they are saying it will be range from 1 to 25, okay, and then mod 26. So this is a stronger method than the previous one, and they are asking for the Caesar cipher substitution function for encryption. It is given by the first option. If you look at the D option, this is for the decryption, okay. If we perform encryption by using this Caesar cipher function, then we will decrypt it by this method, okay, and this is for encryption. So here we have a beautiful question which says the nearest value of 113 base 16 into 3.6 base 8 is, and we have given few options in different bases, okay. So I'll tell you the trick how can we find very easily, and also the standard way to solve these kind of question, okay. So these two have different bases, so we cannot multiply them directly. So what is the best way to convert into base 10, okay. So let's convert them. So 113 base 16 into 3.6 base 8. So let's just convert it. When I convert it, it's 16 1 is 16 plus 1 17, 7 into 270, 272 plus 3 base 10. So I can also say 275 base 10 into it will be 3.6 by 8 is 3 by 4, it is 75, so it's 3.75 in base 10. Alright, so if we will calculate 275 base 10 into 3.75 base 10, you don't actually need to calculate it, because in exam you have no right to use the calculator, so you can just guess it. So this value will be greater than 1000. I have calculated it, and it is approximately going more than 1000, so it is approximately 1031.25. okay, you can guess it that it will be obviously more than 1000, okay. So which is matching with the option B, but let's check the other options also, right? So how we will solve these kind of question is, we will just check that what value it is trying to represent and what is the answer we have got, if they are near to each other or not. We will solve these kind of question by approximation. This is the way how we can solve them very fast, okay? So if we will convert this into decimal, it will be 2 plus 16 plus 8 plus 2. Just forget about this. So it will be approximately 26. So no, A is not the right option. Yeah, B is very close to this. So yeah, B could be the right option. Now look at the C. It is in base 16 and this is 118.8. Right? If you look at this, this is 113 in base 16. So this value is even smaller. Here we are going even multiply by something, so it will be bigger. So obviously this is clearly wrong. Why? Because this one will obviously be get bigger value when we will multiply it by other value, and this one is only 118. Now look at the option number 4. This is in base 8, so let's quickly convert it into base 10. So it will be 32 plus 6, 32 plus 6 into 8 plus 7, so it will be 228 plus 7. So approximately we are getting 235 base 10. I'm just ignoring decimal, they don't make much change. Okay, so approximately we are getting our value in more than 1000, and only B option matches with it. So that's why B is the right option. In these kind of question, what you have to do, you should not, calculate the values on your own, because you do not have calculator. So try to find by approximation. Check what are the other options are trying to calculate the values and what is the value we have got. By approximation, this is the best way to solve these kind of questions. Okay, so here we have a question from Unix. They are asking us the Unix command for this is what it is trying to do. Okay, so they are using the cat command here. Cat command is very useful command in our Unix, and it has many useful functions. Okay, so one of the function I'm trying to show here is, suppose I have a file which is file1, okay, .txt, and I have file2 .txt. What it is trying to do, it is trying to copy the one file content to other, overwrite it basically. Okay, so I'm giving this in example so that you can understand what this is trying to do. Okay, if you look at this, what it is doing is, cat command first will merge these files ABC and DEF, and then it will copy to XYZ. Okay, it will merge ABC and DEF, these two files. This is file 1 and this is file 2. It will merge these two files and then it will copy to XYZ. And out of all options, C option is right for that. Okay, I can also write this one as how? Cat, okay, ABC DEF, okay, on XYZ. This is also one of the way I can do the same work, merging these two files and then copying it to the third file. So option C is right for this.